Good morning. I am Mr. K RATHINA KUMAR, Training Associate, Physics, JIT, Bhubaneswar. Today, I am going to do some of the activities on moment of inertia. For that, let us talk with this. A box is here, and when you are applying the force on the body and the body is not moved, though the external force acts on the body doesn't move. It means that an inertial, that is the resistance against the motion or the applied force that acquired by this body due to its mass. That is why it is not moved. So the moment of inertia is that in case of this, a resistance of this body acting against that force can be called as the pseudo force, which is the inherent property of this body which opposes the external force. That is called the moment of inertia. Let us see this next one. In case of this rod which is tied with the two ends, mass are kept at the two ends of the rod. Now I am trying to move it. So I find some difficult at the center of this rod. So I am feeling difficult to rotate this one. Let it bring these masses near to the center of the rod. Then I am moving. So I feel easier to move this, rotate this. So in this case, the moment of inertia with respect to this rod at the center and the masses are nearby the center, then moment of inertia is less. When it is moved at the ends and the moment of inertia with respect to center, and it is the axis is center of this axis, and is a distance called the radii length called gyration. With respect to this mass, the moment of inertia is more. That is why it is not able to rotate or move easily. So in this case, the moment of inertia due to this rod and with respect to the mass and the length from the center of this rod is more. That is why not able to move easily. Second case, let us have this wooden rod. In this one, keep it the center. Now see that, just rotate it, and you are able to rotate easily. And next case, take it this at the corner. Now I find very difficult to rotate or move this rod. This is because that at the end, the moment of inertia acting due to this rod is more. That is why not able to rotate. But at the center, very comfortable, easy to rotate or move this rod. So the moment of inertia at the center due to this rod is very less, that is able to rotate. This is the second case of this observing activity on this moment of inertia. Then another case, you can see this, a mass of the small circular bodies tied with this, and when I am rotating this one, and you can observe that the speed or the speed of the ball or the which is greater or not, you see. When the length of this thread it is going to be reduced and it moves faster. When it is increased, it gets slow motion. See that? When it comes, it is moving faster. So in this case, the axis of the rotation, when the ball which moves, the longer length will move a circular very slowly. Circular motion, that is a rotational motion, is very slow. In case when the radius is reduced, the length of the rod is reduced, then the ball rotates fastly. So this is the application of the moment of inertia. If this, according to this one, I is equal to mr square, when r is less, then the moment of inertia will be more. When the distance or the length of the rotation or the radius of the gyration is more, then the speed of the motion of the body will be less, and accordingly the moment of inertia is less. Another case we can see that now you are observing this two type of the wheels. One is a smaller, let us see here. The another one is the bigger. So now I am applying the force on this one. Let's see what happens. It moves faster. See that? It moves faster. Again, see that applied force. And in the second case, moving slowly. So this is according to the shape of the body and the mass with respect to rotating through its axis, the moment of inertia is less or more. We can conclude that the moment of inertia acting along the axis of the rotation of the body is more with respect to this inertia. That is called the moment of inertia. I hope that you might have understood the moment of inertia from the simple activity, and you can also do a simple activities to explain the moment of inertia. Thank you very much.